Hey guys, welcome back to the shop. We got a pair of axles in front of us here that need a slight modification done to them. My local mechanic friend, Phil, he brought these to me. Said that they go into a GM 12-bolt rear end, I believe in a C10 pickup truck. And they want to install these C-clip eliminators right here. So these bearing drills need to be turned down to fit this. It has a very slight interference fit. So this kit is from Strange Engineering. And what these will do, for anyone that may not be familiar with how these rear ends work, these axles here, they go in from each side, and then you have these C-clips that go in this with the differential. And those C-clips is what eliminates or what prevents the axle from sliding all the way out the axle housing. With the C-clip eliminators, and I may be mistaken, I believe this is like a Ford 9-inch style. The bearings are pressed onto the end of the axle there, and that's what helps prevent the axle from coming out. Now, that may not be completely accurate, but with the addition of the C-clip eliminators installed on the axles, in the event that these axles are broken, because they're going to be used for hot rod stuff, burnouts, in the event that the axle is snapped and broken, it doesn't let the axle just slide out of the housing. This bearing, that's an interference fit on the journal there, keeps the axle intact in the housing. It just breaks it. So that's all they need done, to set these guys up and turn those journals down. We have a dimension here that was given to Phil by Strange. They said that it needs to be turned to 1.532 inches. I'm going to do some measuring here to see how that matches up real quick. And Phil brought them all nasty and oily and dirty, so we need to go over to the smart washer and get them cleaned up. So let's just see what the axle is measuring now. That one there measures 1.618. That one measures 1.619, so 1/1000th difference between the two. Yeah. All right, I got some telescoping gauges right here, and we'll just go ahead and measure what this bearing diameter is and compare it to what Strange says to turn it to. They want it 1.532. And the bearing is measuring 1.531 and 531 and 5/10. So that's going to give them a 0.5 interference fit. That sounds about right for something like this. I'm going to go ahead and measure it one more time. .531, and I got 0.6 that time. So 0.5 interference fit. So we've got a pretty close tolerance to hit that on. But we're going to go ahead and we'll do this in the manual lathe. We'll go over to the Precision Matthews and get these set up, and probably chuck on the spline in here. And let's see, they do have centers cut from the factory. I need to clean them up. So we'll just run a live center in that end of the axle right there and get the journal turned. All right, I think that's what we're going to do anyway. So I'm going to go get them washed and get them cleaned up first before we go to the lathe. Let's get one in the lathe and see if it's going to run true. So by the way, I did take some emery paper and I cleaned the center, the factory made center in that. Let's see if it's going to run true with that. Should be able to clamp right on the OD of the splines there. Got them 6 jaws. Should be plenty of material there. Catching. Go with medium range here. Well, that's not running true. That ain't gonna work there. The center is not true with the journal there. It's actually running out. Yeah. I mean, it looks, when you're looking at the axle, it looks like it might be bent, but I think that's just how it was made there when it was forged. But the journal is not running true with this flange here. It's running out. Man. I guess we could try doing it the other way, flip it around, maybe catch this flange. I just like doing the center because you know that's where the factory made it, but it is not running true. In fact, we'll just put an indicator on there and I'll show you what I'm talking about. You guys can see that, I think. Let's just put it right there where the bearing goes. Yeah, that's a good 10, yep, 10 thousandths run out right there. All right, so we're gonna have to rethink our setup. I think maybe we'll try flipping it around and maybe just catching the flange and seeing how that would work. That's not out too bad, but man. All right, I got to rethink my setup right here. You know, this is a classic. This won't take you long. This is a quick one. Just chug it up and turn it. Take you 5 minutes tops, right? This is the kind of stuff you run into. It's the setups. Turning it is the easiest thing that we have to do. We need to make sure that it's set up properly, running true before we cut that. This is the second axle. I wanted to set it up and see if it's doing the same thing as the first, and it is, exactly. And what I noticed was that when I paid closer attention to the center, it looked like the live center here was not actually touching on the center that's cut in there, and I could see it moving around. I think that the smaller hole that they have up inside that axle is not deep enough for the point of the center, and I think it was just sticking in the very end of the center there. So I got a different center, and I have this insert here that I think we can put in there that should catch that larger portion of the 60-degree center. So I'm going to swap this out and put this guy in here. This is where it pays to have a lot of different live centers. It's this one. This is a TMX live center, so I need to knock this one out and put that guy in there, and then we'll try it and see if it runs true. All right, here's our TMX center. And then we got a wedge that comes with this kit. Should knock it out of there. Yep, there we go. I don't have a soft blow anywhere near me. Get this little brass punch though. There we go. Now, let's see if that makes a difference. All right, we still got a little bit of run out. Still got a little run out, so I think I can see the axle slightly bent. Maybe this is an old axle, so maybe they do get bent over time, especially if people are out there hot rodding them and doing a bunch of burnouts. I don't know. Still getting run out, so that's 3, 4, 5, about 5.5 thousandths run out. So it cleaned up some of it, but it's still not running true. I have a couple of options that I'm considering. Setting up the steady rest here on the journal and recut the centers. That's one way to do it. or put the 4-jaw on over there and then chuck this flange and just indicate the journal running true. I think that's definitely a great way to do that. I really don't want to have to flip all those jaws around on that 6-jaw chuck. And one more thing that I really need to check though is how the center on the splined end looks. If that's not a good center, then it's really not helping us out a whole lot. Let's see what we got though. That looks like a good center in that one to me, but I don't think we'd be able to chuck this. 1, 2, 3, 4, 5. I don't think we're going to be able to get that in there. It's just not going to, all those studs would be in the way. All right, I think what I'm going to do is I'm going to take my 6-jaw off there. I've got my 4-jaw right here. The jaws are already turned around where it needs to be. So we're going to use this guy and chuck that flange and just get it trued up. So yet again, my plan was foiled because the studs sticking out the back of the axle wouldn't actually allow me to catch it on this step here. So I'm just turning the jaws around completely, and we're going to be hanging these jaws out just about as far as we can to be able to hold the flange so we can true it up. And I have already run the carriage in here, so you have to check this kind of stuff. So when you run your carriage in, you don't want it to hit the, this part of the carriage on the jaw. So that's got to clear. But with those two there, let me just make sure we're at 6.6. That's 6.5 right there. So another 50 thousandths per side should hold that thing. So maybe we'll get it set up today. I hope. That's what I'm working on. I was certainly hoping that we would already be turning one of these axles by now. Going out to the 1, 2, 3, the third line, get it lined up, and then I go half a turn. Quarter turn, quarter turn, quarter turn, and a quarter turn. That might, yep. That looks like that's going to work right there. Just set that there for now. Use the center here to hold it. Got the, just showing you, we got the live center in there. We still got this loose. And what I'm going to do is pull this back. I'm going to have our chuck jaw ready to tighten up. And just put it right there on that end, into the flange. Like so. What you need them 4-jaw chucks for? You can do everything with a 3-jaw chuck. Kidding, obviously. You learn a lot when you film your work and put it on social media. When you're so used to doing things a certain way your entire career, and then you all of a sudden have a lot of people watching you and telling you difference of opinions anyway. Okay. How far out we are? About 50, a little over 50 thousandths. Okay, here, let me get you guys moved in here. Can you see this? You guys usually like the 4-jaw action. There's your high, there's your low. I'm going to start with the high just to make sure that it's snug. And then we'll go ahead and just start bumping the low, tighten the high, go back to your low, loosen your low, tighten your high. Low, high. Now the low's there, the high is there. Three or four thou. Tighten your highs once you get that close. Half a thousandths. Think we can get that out of there? I doubt it, but what I want to do is make sure all 4 jaws are tight I don't want it coming out of there. I don't want it loose. Sometimes you'll have 3 jaws that are tight, one's still loose. So you might have to go in there and adjust it a little bit more. So I think we got it there. That's moving maybe a 1/2 thousandths on the dial indicator. See, I moved it right there because one of those jaws were still a little bit low. You just watch for that high. There you are, a 1/2 thousandths again. Okay, that should be good, but let's go ahead and check this tailstock end. I'd like to see if this end that's actually been turned where the C-clips go is running out any. Okay, you got about a thou, maybe a 1.5 thou run out. So we know that that's going to be acceptable where it's at. So this is good. All right, I think we're ready to start turning our journal. It's foiled yet again. I put the tool in here. I wanted to go ahead and double check our clearance, and lo and behold, if you run this up there, kind of where I got it set where we got to turn, jaw's going to hit, just barely hit this side. The other side is actually clear, but I think what we can do at this point is I'll go ahead, I'll turn the compound slide around here straight with it, and we can run this tool out further to be able to get to the end of the cut here before we get into our jaw. All right, we'll see if this last little step is gonna get us fixed up with what we're wanting to get accomplished today. We'll just spin this around to 0. And see if that is going to fix this up. I got to square the tool up. We'll go ahead and run this in. Let's see where we're at right there. Yeah, all right, so we can go out just a little bit more with the compound slide, and this will get us right up to that radius where we're gonna cut to. And this is what I always do in jobs like this. Anytime you've got a little bit of consideration on clearing your chuck jaws, just spin this by hand before you ever spin it up. If it clears by hand and you don't have to run that tool any further up in there, you know it's going to clear. So we're good to go there. I've got about 3/4 of an inch between the end of the carriage and the jaw where it would hit it. And we don't have to go that far anyway because we've been into the radius there on the journal. So I'm going to go ahead and lock that in place right there. And I think we're ready to turn it. No, I need to turn my tool first. So let me do that first. I'm just going to eyeball it square. That's good enough. We're just turning it. That's all we got to do, turn it. And that gives us even more clearance there, about 1 inch clearance now. All right, guys, I think we're ready to start turning it. Okay, we're ready to cut. I'm going to get my touch off. I'm not going to use my mag back indicator down here like I usually do because it's way too close to this chuck jaw. So we're going to go off of the DRO for this job. I just want to come in here. I'm going to touch off in X. Just get a 0 point established and try to, there it is. And then this is probably going to be some hardened steel, I'd imagine. It's already feeling that way. So I don't know how our tools are going to hold up, but what I want to do is just come in there. I can see the radius right there starting, so we're going to zero out our Z. I'm going to go ahead and zero out our X. I might have burned up my carbide insert right there, just rubbing it. So we've got, if we just do the math, we've got, in theory, 87 thousandths to come off of this thing. This is probably going to be hard, so let's go ahead and trying to chatter on me. Let's slow it down. That's 380. Let's run 250. Let's see if that'll help us. All right, I think that's got the chatter out of it anyway. Did you hear that squealing? That's perfectly normal because that's hardened steel that we're trying to turn. Once we get to the end where we zero it out on our Z, each step I'll just back off a little bit, and then when we're done with the job, we'll go in there with a full radius tool and cut that radius to try to transition it a little bit better than a square edge. That's our 0. We'll reset. We'll take another 25. We got 20 thousandths to take off of that. I'm going to go ahead and swap out the corner of my insert, start with a fresh corner, and see if we can get the last 20 off of that. Index that carbide insert. We're going to go in another 10 thousandths. We'll make a pass there and see how it does. I definitely wore out that tip a little bit, but I think we're at a pretty good speed for what we have here. That tool looks like it's doing better. Yeah, that's looking good. That's sounding good. Thankfully, no more chatter. You can hear that. Now you're getting into that really hardened part of the shaft. Right in here where the tool starts cutting, and it's cutting offside because you can see the run out here. Probably the way it was naturally after it was forged, heat treated. And it's a little bit softer right here, and it gets harder as you get up into this area. I believe on this pass, when we get to the end, I'm not going to back off of it now. I was backing off just to try to help save that tip, but I'd like to leave it where I've got it because we need to sneak up on that size. And this is the kind of situation where you've got a lot of pressure against that tool with that hardened steel. So just because you dial in something on the cross slide doesn't mean that's what you're going to take. It actually takes usually less than what you're trying to cut, because it's simply just trying to push away from that carbide insert. And that's why you'll see the drag marks a lot heavier on something hardened like this. That right there, that's what I'm talking about. But not as bad as it was earlier that we indexed that tool. I tell you what I used to use back in the day, I always had a diamond tip. I believe it was CBN tipped insert. And those inserts work really good for hardened steels. And you know, I haven't used one in a long time. I don't even know if I got one hidden around somewhere. 37. 37, so that means we got 5 thousandths to come down off of this thing. So it ended up taking more than what I was wanting, but probably because we indexed that insert now that we got a good clean edge on it. I'm just double checking myself here. Yep, so where it's at there, I think I feel a little bit better if we just take a couple of thousandths and then mic it and then try to land on our size. All right, I'm just going to dial in 2 and we're going to let it cut. Okay, hopefully this is gonna end up being our final cut on here. $35. So let's see, 32. So we got 3 thousandths to come off. I'm gonna double check. That's 35. It's like 2/10 over 535. Okay. 32, 3, 4, 5. So I think we're gonna be good if we dial in 3 thousandths and take our final cut. I'm gonna dial in 2.5 thousandths. I'm gonna look down here on the dial. Let's see if we can get it right here. There's 1, 2. All right, there's 2.5 on the dial. Looks like we hit it right there. Okay. Final cut, hopefully. Right there. Okay. I'm actually a little bit nervous about this size, so since you got a long journal there, I'm gonna stop it. I'm just giving it a little bit further to go here. I'm gonna stop the feed anyway, back off, hit the foot pedal so that we don't rub that insert too much. And I just want to check my size right here and see if we are on what we want. And that is 532. I don't know if you can see that, but that is 532. And just double check in our paperwork, 1.532. All right, so that's good. Now, the only problem with that is you'll see a little bit of a line there where I stopped it, but that's not big of a deal. I think that's a good trade-off, being sure that we don't turn that undersize. So we'll go ahead and just engage the feed and turn the lathe back on. Just like that right there. So you'll see that little bit of a line where I stopped it, but that's not a big deal. I'd rather be on size. All right, there it is. Now I'm still gonna come in there and clean this radius up there. We're gonna do that last, but I wanna go ahead and give our journal a measure. And that is 532 on the mic. We hit that perfect. Good, that makes me feel a lot better. Now if only we can do that a second time. All right, so we're gonna take this tool out, the turning tool, and I'm gonna find a tool that's got a pretty good large radius on it that we can come in here and clean this up. I pulled this one out of the cabinet. It's another MX22 tool, but this one right here is 5, what did I just measure that being? I believe it was 5 millimeters, so around 0.2. Yeah, it's a 5 millimeter wide. So that's a pretty nice radius. We'll go in there and clean it up with that guy. Take a little at a time until you get down to the bottom and clean that radius up. Want a good clean transition. And that doesn't help right there. Okay, all right. You're making me do what I don't want to do. I had to take the tool out, clear the chip. Now we'll come back in there. I think we're just about at the bottom now. All right, there we go. All right, well, our first axle is completed there, so we can go ahead and swap this guy out and start on the second one. We'll show you some setup and indicating on the second axle there, and just give you some highlights of the turning, because it's going to be the exact same thing that we just did right there. Okay, what we can do is you can just loosen your tailstock. You don't have to slide it back. That way it's still holding the end. Just loosen 2 of your jaws of the 4-jaw. Before you crack it all the way loose, I go ahead and hold on to it so it doesn't slip off. And then just push the center back like that. Grab the next specimen and bring it in. This time what I'll do is slide the center in. All right, and then now that it's got it held there, we're gonna snug up the center, or the tailstock I mean, and then go ahead, snug that one. Now it's there. Come back around to the second jaw you loosened and snug that one up, just like so. Go ahead and make sure the tailstock's locked good. And we are ready to indicate. About 30 thousandths out. We'll start with our high. See it move? That's why you always start by snugging up your high spots. It kind of puts tension on both jaws there. All right, now we just move to our low. High, low. That's within 1/1000ths. So go to your high. Now you might move it too far. That was our high. Now that's our high. Not by much. 1/2 thou. Now we'll go to these other two. That looks like a slightly low. So we'll snug that one, make sure it's tight. Now that one's high. See that? You keep moving it because you got to get enough pressure on the jaws there to hold it properly. That's within 1/2 thousandths. I'm just gonna check all 4 jaws like this. Feels nice and tight. That's less than 1/2 thousandths right there. So I didn't even count. How long did that take us? A minute, maybe? It's not too bad. All right. Just gonna go ahead and measure this just to be sure it's the same. Yep, that one's 618. That was our small one. All right, so we're ready to turn. I believe I told you guys the wrong speed earlier when we were turning. I was in number 2, which is actually 180 RPM. I think I said we were doing 250. So I just wanted to correct myself there. Come on in here and touch this. This should be close to a 0 here. There's our touch off. We're 2 thousandths over the 0. That's good enough. I'm going to go ahead. I've just been using this X0 just to kind of keep up with my position. And I'm only taking 25 a pass. So 25. Come in until it starts rubbing. All right, all the way up to the journal. That tip is doing much better than one we started with. I think it was already wore out. Unsweetened tea, by the way. I really don't drink soda. Enjoy a cold beer on the weekend, but unsweetened tea for me. Had some really beautiful weather this week. What temp is it right now? It says it's 70 degrees outside. Humidity's starting to come back in though. It's supposed to rain a little bit this weekend, I think. But last few days have been really nice. And Abby and I have actually been busy moving all the stuff down here from the home shop. I needed to stop and take a break and get these done for Phil. There's our shoulder. It was 6 thousandths off on the DRO. I'm gonna go ahead and take another 5, 10, 20. Oh yeah, look at all that rubbing. Man, that's a long way to go right there. Long way to go. Much better. All right, that sounded like it just got the insert right there. I think it chipped it. You can see it's a different chip as well. All right, I need to stop it and check that. I was going to, but I'm just going to go ahead and finish that pass there, and then I'll back it out and check it. But I think it chipped the insert. Let's see if I'm right. Yes, the very corner of that insert chipped off of there. I could tell the difference in the pitch, the sound when it was cutting there. You get used to that. Use these turning tools enough, you'll know when it snaps or chips the end of it. All right, we indexed that insert. We're on the, I think that was the last corner available on that one. Let's see where we're at on our sizing. All right, 75, 678. We're at 578 right now. I started turning this, and I think I'm going to change up my plan there because it keeps getting further and further away of where we need to be. I think I'm going to put that insert tool in here that we were using on the last one to clean up that corner. And let's just undercut this a little bit. We can just go right up to this spot right here and just undercut it and get that taken care of. I'll kick up the feed a little bit. Let's go to a LCR 4W. No, LCR LCR4W. Yeah, all right, that should be 11 thousandths right there. I'm going to run this up with that radius tool and see if that will see if that'll clean it up enough where we can just do our turning up here in this area. Trying to chatter on us, a little bit heavier cut, but that right there should help us out and get rid of some of that area that the tool's trying to turn, and that way we can just focus on this spot right in there now. That is better right there. You know what I forgot to do? I forgot to drop that feed back down. Match what we were turning before. Let me go back over that again. I think I'm at my final pass on the second axle here. Let's see what we're miking. 38, 5, 35, 6, 7, 538. That's 538. About 2/10 smaller on this end than this end right here. Yeah, about 2/10 difference on the mic. So 2, 3, 4, 5, 6, 7, 8. That's 6 thousandths that we need to dial in. And let's see. 4. There's 6. Okay. Look at that. You've got to be kidding me. You got to be kidding me. Well, there goes that. I was touching there where I turned it down. All right, I'm probably gonna have to index that insert again. I'm gonna have to go back in there with this guy because I needed a little bit more off of this guy. All the way down here. Let's do that. I did not think that that tool was going to touch that undercut area, but we're just going to undercut it again. So we took that undercut and I touched off and just dialed in 2 thousandths just to try to get a cut established on this guy, and we will mic it. And hopefully we'll have one more pass to make it 2 or 3 thousandths. All right, where are we now? That's 36, so 4 thousandths. That's 36, so it looks like we got 4 thousandths. 36, I'm just double checking myself. Let's see, we're in the middle, 36. 2, 3, 4. So we got 4 thousandths. Okay, let's see if we can hit our mark. We got our DRO is zeroed up there. I'm just moving it a little bit because sometimes it'll change on you. There we go, 4 thousandths. All right, it's taking a cut. I hope that's it. All right, where'd we land? 32 and a half. 32 and a half. Got about a half a thou over on that one. That's good though. Better than being undersized. All right, so what we're gonna do is something that people will annihilate you for doing it, but we're gonna do it because I need to do it. And let's give it a shot. So I've got some of this, some 320 right here. I don't like showing this in videos because of what I said. People will give you a hard time, but in reality, I doubt there's a machine shop in existence where machinists don't do the exact same thing. But when you show it in videos on YouTube, it's a different story. That means you don't know what you're doing and you're damaging your machine. All right, that took a couple of tenths right there. A couple of tenths. So I need to do that a little bit more. All right, so you saw what I do right there. It's going to take the high spots off of the tool marks there, so it's pretty easy to get 2 or 3 tenths down. Sometimes you just have to work it a little bit, and I may have to go to a little bit stronger grit, a little coarser grit. You can see the material right there. But that is what is going to get us on our size right there. It looks like I've still got about 2 tenths to come down to our dimension that we are wanting. So I'm going to keep working it a little bit with our emery, get those last 2 tenths down, and then this will be finished up. Okay, I got that polished down, and I think it's nice and straight and where we want it. So let's give it a check here. Will it focus on that? Looking for 532. .532. .532. That one might be 1/10 over. It might be a tenth. I think we can live with that though. All right, last up, we just need to clean up that radius in the corner. All right, both of our axles are now complete. Let's go ahead and get this one out. Reverse our process, loosen the tailstock. Loosen one chuck. Hold on to it. Loosen the second and push that one back. There we have it. I've been thinking about it a lot. Just for sanity purposes on my end, I think I want to go ahead and undercut this. This is the first one we did. Go ahead and give it a slight undercut to match the width of the journal that we have on this one here. So I think I'll go ahead and do that. It's going to make me sleep better at night knowing that we can at least have an undercut on there to where when the bearing goes on, it's the same diameter like this one right here and not different diameters because of all this. So I'm just going to do that off camera and get that knocked out, and that'll finish this job up. All right, guys, well, this job is wrapped up. I'm real happy with the way the axles turned out. We have both of our journals turned nice and straight on the dimension that we wanted there, which was 1.532. Yep. We hit both of our journals on size so that they can take these guys here that's got that bearing and press them down on there. Interference fit, if you will. The Eliminator kit that they call these guys. So it just makes it it makes the rear end, the axles, safer to use when you're going to go out, you're going to do drag racing, or you're going to go do some smoky burnout somewhere, so you don't risk, if this thing breaks, an axle sliding out on you and causing all kind of havoc and problems on the road. So anyway, that's what this is for right here, and that should get them going. Phil can take these things and get it back installed. He was installing a positive traction unit in this rear end as well, and I think that's all the guy wanted was a posi unit in his truck and the C-clip eliminator kit. But anyway, this right here was another good example of how even something that should be seemingly routine and simple, you chuck it in the lathe, you turn it, and you're done with it, right? It ain't always that easy. Sometimes you run into issues, which is what we did right here, and you have to learn how to improvise and get around those troubles. Sometimes it's a feed and speed issue. Sometimes it's your tool. Pay attention to your carbide inserts, because even though you think that you might have a good edge, a good corner on that turning tool, it may be chipped. Not where you can see with your eye, but you get a magnifying glass, you can see sometimes the corners on those inserts are just chipped out enough that it's putting a lot of pressure against that. And sometimes that can cause chattering issues as well in the lathe. So pay attention to your tools. You got to have a really good tool to turn this hardened material like that, that's not chipped or worn out. And mind your speeds there as well. If you try to run that any faster than that, it was right on the verge of trying to chatter on me. And if you would have sped that up any faster, it would have chattered on you, and then that just leads to another set of issues you got to deal with. And then you could obviously grind this if you had a tool post grinder, but I think this is a little bit extreme for a tool post grinder. You could certainly get it turned down really close, I'd say less than 5 thousandths, and then put your tool post grinder on there and grind it. That's a great way to get it done there as well, but I think it's unnecessary. It just takes a lot more time for a job like this. I'm not saying it's not the right way to do it, but for this particular job, I would not set up a tool post grinder for. I think it needs to be something much more extravagant than a couple of axles out of a GM 12-bolt rear end. But anyway, as I said in the last video, you know, I just try to be as helpful as I can whenever we are filming these projects and sharing it, showing the setups and how you set a part up in the lathe, how you get it indicated, and then when you run into issues, you know, the things that you got to check and change up in order to get the job done. So I hope that it was helpful to you guys out there watching that are trying to learn. And if you're here for the entertainment value, well, I hope I entertained you today, and I hope you enjoyed the video. So hope you guys come back for the next project. All right, we'll see you then.